All right, today we are in section 1.4, and we're going to be taking formulas and rewriting them, or any kind of equation, and able to write it in a way in which we get one of the letters by themselves. So here is your vocab word. Today we're going to be talking about literal equations. Now, an equation that has two or more variables is called a literal equation. To rewrite a literal equation, we must solve for one variable in terms of the other. So I'm going to say that one more time. To rewrite a literal equation, we solve for one variable in terms of the other variable. What that means is you're going to get one variable by itself, and the other value of the other variable, we're going to treat kind of like a number, and we're going to move it to the other side. So example number 1. Let's rewrite this equation. We have the equation 2y plus 5x equals 6. Now this is a literal equation. Why? Because this equation has a y and an x. So we're going to solve this equation for y. And here's what that means. That means we have to get the y by itself. Everything else goes to the other side. So in this case, what we have to do is we have to pretend that x is just kind of like a number. Even though it's not, but we're just going to move the plus 5x. That's it. It's the same thing as if you had 2y plus 5 equals 6. You would subtract 5 on both sides. Well, I need to get rid of the minus 5x. And we're doing that by using the subtraction property of equality. Now, that would give me 2y equals. Now, here's the important part. You can write this a couple ways, but I want you to understand that you cannot take 6 minus 5x and get 1x. These are not like terms. So you could write this as negative 5x plus 6, or you could write it as 6 minus 5x. It's completely up to you which way you want to write this. You could just say 6 minus 5x or negative 5x plus 6. Either one are the same things. Now, I'm going to solve this two separate ways. So now I have to get rid of a times 2. So what are you going to do? You're going to divide everything by 2. Now, we'll just continue on and do it a different way. So these 2's cancel. So that gives me y equals negative 5x plus 6 divided by 2. But here's the problem. We can actually simplify this more. Because each of these terms are being divided by 2. You're dividing the negative 5 by 2 and the 6 by 2. So I could write it like this. Negative 5 halves x, because I don't want a decimal. You can just leave it as negative 5 halves. But 6 divided by 2 is 3. So I could write this as y equals negative 5 halves x plus 3. Now over here, I could do the same thing. 6 divided by 2 is 3. Minus 5 halves x. Either one is correct. But now let's solve this exact same problem. Let's solve it for x. I know this problem doesn't say to do that, but we like having fun. So we're going to actually solve this one for x. So now what you would do is you would now get rid of the 2y. Well, how do you get rid of a plus 2y? You subtract 2y on both sides. So that would give me 5x equals negative 2y plus 6. I now have to get rid of a times 5 by using the division property of equality, by dividing everything by 5. Now notice what I did here. Over here I divided everything by 2 and then separated it. Here I divided each of them by 5. No matter what you do, it's the same thing. This would give you x equals negative 2/5 y plus 6/5. And that would be your answer. Now you could change, if you wanted to, you could change this to plus 1 1/5. You could change this to negative 4/10 or negative 0.4 y plus, and then you could change that to a decimal as well. It's completely up to you what you want to do. But improper fractions are going to be the way to go here. Now, if you want, you can do these problems on your own, but I'm going to do them all for you. But you can pause the video, you can skip over them, it's completely up to you. Actually, let's go over the first one before I go on to the second one here. I want to make note of something. Here I added x on both sides, and I got x plus 10. I then divided everything by 5. But notice here that in front of this x, I actually have a 1. So this is going to be 1/5 x. Now, I also want you to understand that what you're doing here is just moving these to the other side. And when they move, the inverse operations happen. So this is a minus x, or a negative x. You move it to the other side, it becomes positive. So if you want to skip this step right here, you can do that. All right, so now going to number 2, because this is where I see a lot of mistakes. A lot of mistakes. I have to move the 4x. That's a plus 4x. So if I move it to the other side, it becomes a negative. So that gives me negative 4y equals negative 4x plus 1, or you could have 1 minus 4x. Either one works. But now I divide everything by a negative 4. That's the mistake I see a lot of. You have to divide everything by that negative 4. Now some people always ask, Mr. Humphreys, why did I not divide by this 4 right here? Why did I subtract? Because here I did not want to separate the 4 and the x. I just moved the whole thing to the other side by subtracting it. Here, this is negative 4 times y. And I'm getting rid of the times negative 4. I'm separating the negative 4 from the y. So that would give me y equals negative 4 divided by negative 4 gives me 1x. And then plus 1 minus 4 would just give me negative 1/4. And that would be my answer. The last one would give you 4 minus 2x equals y. In example 2, we're going to rewrite a formula. Now remember, a formula shows how a one variable is related to one of the other variables. A formula is a type of literal equation. For example, the area of a rectangle is base times height. Here's what the problem says. We have a formula for the surface area, S, of a cone that's written like this. We want to solve that equation for the slant height, L. So here's my equation. S equals pi r squared plus pi r L. Now you may ask yourself, really? What in the world do I do here? I want you to first look at this and say, okay, I want to get this L by itself. So what do I have? What's happening to the L? Well, I have pi r times L. Well, I don't get rid of that first. Or I have a plus pi r squared here. Now, I want to make note that this plus here does not go with this pi r squared. This plus goes with this, the entire term. But I want to move this plus pi r squared to the other side. So I'm going to use the subtraction property, and I'm going to subtract pi r squared to both sides. So that gives me s minus pi r squared equals pi r times L. But now I want to keep this L here, and I want to get rid of the times pi r. How do you get rid of times pi r? You divide both sides by pi r. So that would give me L, that's all cancels, L equals s minus pi r squared divided by pi r. Now you actually could simplify this. Now you can't just say, oh, the pi's are gone here, because both of these are being divided by pi r. Now when you have a formula, I would just leave it like this. If you wanted to, you could do this. S divided by pi r minus pi r squared divided by pi r. And then this would stay the same. You can't do anything with this. But then the pi's would cancel, and then the r on the bottom would cancel, and one of the r's on the top would cancel. So you would have this. So either one of these would be acceptable, but you're going to see this more often. You can skip this part, or you can try these four on your own. Here would be 3 examples with their answers that have been completed. Here's your key idea. This key idea is a formula for converting from degrees Fahrenheit F to degrees Celsius C. The formula is C equals 5/9 times the difference of F and 32. Example number 3. Let's take that formula, C equals 5/9 times F minus 32, and we're going to solve this equation for F. Now I love this because this is where your smarts and you're working hard and understanding an equation, you can make this much easier. Now, here's the hard way. You could distribute the 5/9 and then move the minus fraction, add it to the other side, and then go from there. But you can get rid of the 5/9 first. The opposite of times 5/9 is multiplying by the reciprocal. So that would give you 9/5 C equals F minus 32. The 5/9 and the 9/5 cancel. The last step is adding 32 to both sides. So I add 32 to both sides. That gives me F equals 9/5 C plus 32. That's it. Of course, it would not be fun without a real-life application problem. So let's put this on here. We'll talk about the sun at 11,000 degrees Fahrenheit and lightning at 30,000 degrees Celsius. So here's the question. Which one has the greater temperature? So we either convert them to both Fahrenheit or convert them to both Celsius. Well, since we just solved the Fahrenheit one, let's use that. Fahrenheit equals 9/5, whoops, that's not right, 9/5 C plus 32. Well, Fahrenheit, I don't plug the sun in, but I can plug the lightning in. So that would be Fahrenheit equals, it's going to be plugged in for C, 9/5 times 30,000 plus 32. Just plug it in, solve it, 30,000 divided by 5 times 9, 30,000 times 9/5 plus 32 would give me Fahrenheit of 54,032. So this is 54,032 degrees Fahrenheit. And the sun is 11,000 degrees Fahrenheit. So which one is a greater temperature? That would be lightning.